most everything we do is always the statistic. It's very hard to actually find the actual population mean. We depend on samples to tell us about it. Um, like we can never find every single owner of a truck. Instead, we have to take samples from towns or something. Um, to get a good idea of the population, we have to take many random samples to tell us about the population. You can't just take one. Um, and you'll get sampling variability, which when you repeat the sample, your statistics should be different each time. Like if you poll 20 people and the first time you have 9 of them are truck owners, and then the second time you poll, you're probably not going to get exactly 9 again, but you could get 10 out of 20 are truck owners. And what you would do is you'd want to keep continually to sample, and hopefully that will tell us about the population. The distribution of values taken by statistics in all possible samples of a sample size from the same population. That is a sampling distribution. Let's take a look at all of this. So here's what they did is we have a card of or a deck of cards, numbers 2 through 10, and what they want you to do is take 100 simple random samples of 5 cards, and then find the median. So the first one says there is one dot on the graph at 2. Explain what this means. First of all, one dot represents one SRS of sample 5, of size 5. And what this means is the median for this one point is 2. B asks about describing the distribution. Whenever you do distribution, you must talk about shape, center, and spread. The shape of this is, I would say this is unimodal and roughly symmetric. The center, well, the mean of this, where's the highest peak? The mean is about 6. Notice that's the tallest peak up there. And then shape, center, spread. Our spread goes from 2 to 10, but most everything is probably in between. Looks like 4 and 8. And then they ask, are there any obvious outliers here? I would say no. It looks like all of those are pretty good right there. C asked, would it be surprising to get a sample median of 4 or smaller in an SRS of size 5? So let's go ahead and take a look at how many of them are actually 4 or smaller. So you got 1 in this column, 6 there, and you get 15 up top. So that means we have 22 out of 100 trials that are 4 or smaller. So I would actually say no. Getting the sample median of 4 or smaller occurs fairly often just by chance. In fact, it's a 22% chance or 0.22 probability. So I would not find that surprising. If it was like 3%, 2%, 1%, yeah, but 22%, no. And the last one says, suppose that another student prepared a deck of cards the same way, and you take a simple random sample of 5. The median is 4. Does this provide convincing evidence that the student's deck is different? Getting a sample median of 4 does not provide convincing evidence that a student's deck is different, because if looking back at C, we had a 22% chance of getting 4 or less. So in reality, this doesn't really tell us anything differently. Let's take a look at another example. This is 200 chips, and 100 of them are red and 100 of them are blue, and we're taking 500 SRS's, simple random samples of 20. And it says there's one dot on the graph at 0.15. Explain what this means. So remember, each dot represents one SRS of size 20. So if one dot is 0.15, well, how many red chips were pulled out of that? And just using pretty simple math, we see we get 3 red chips, and that our probability was 0.15 for pulling out 3 out of 20 red chips. Describe the distribution. Are there any outliers? Once again, shape, center, spread. In terms of shape for this, it's unimodal and roughly symmetric. The center, well, look at what the highest point is up there. In the center, it's around 0.5. Spread, the total spread is 0.15 all the way up to 0.8, but it looks like most of the data is going to be in between 0.3 and probably 0.75. And are there any obvious outliers? The only outlier that looks like we have in this graph would probably be right over there. Is it really concerning? No, but it definitely sticks out just a tad. C asks, would it be surprising to get a sample proportion of 0.85 or higher in a simple random sample of size 20 when the probability of getting a red is 0.5? And just looking at what we have, we actually don't have anything above 0.85. So out of our sample, we took 500 simple random samples here. So out of 500 simple random samples, we got 0 above 0.85. So yes, it would be surprising. And then the last one is suppose suppose I prepare a bag with 200 chips and claim that half of them are red and half are blue. A classmate takes an SRS of 20 chips, 17 of them are red. What would you conclude about my claim? Meaning, do you actually believe that half of them are red? So 17 out of 20 is that 0.85. And notice in these 500 samples, 0 were 17 out of 20. And the first time you pull out of my bag, you get 17 out of 20 red, yeah, I think that's pretty alarming that over 500 simple random samples, we got none. And then the first time you pull out of my bag, you get 17 out of 20. That's pretty alarming. So I would definitely say this is strong evidence. This is strong evidence that my bag is not 50-50, meaning 50 red and 50 blue.